Welcome everybody to UG Academy. In this video, I'm going to talk about recursion in C++. In programming, recursion means that a function calls itself, and then this feature is available in C++ as well. Recursion may seem strange at the beginning, but it can actually make our code look much nicer and easy to understand. In this video, I'll use Fibonacci sequence as an example. Fibonacci sequence is a well-known sequence in mathematics, defined here. The zeroth term of the sequence is 0, the first term is 1, and then the nth term of the sequence is given by fn-1 plus fn-2. So this sequence should be very well known, you have already heard of it. So following this definition, we are going to write a function that output the nth number within the sequence. First, let's have a recursive version as an example. Using recursion, we can very naturally adopt the definition of the sequence. First, we will need the base case. The base case is just these two cases divided here, okay? And then if the n is equal to 0, then we return 0. If n is equal to 1, then we return 1. This is the base case. And then, if not within this two base case, we call the function again. Fn Fibonacci f-1 and Fibonacci n-2. It is exactly what this function here. It calls itself. So the n here will keep decreasing in every function call within itself, eventually reaching the base case divided here. And then eventually, it can calculate the nth number within the Fibonacci sequence. So this is the application of recursion. It very naturally follows the definition here, very naturally, and the code is very simple. There's only 5 lines of code within this function. If we are not going to use recursion, we are going to need much more lines of code. Here is a non-recursive version doing the same thing. So everything becomes much more complicated. We first have to define 3 integer variables to keep track of fn, fn-1, and fn-2. Okay. So we have to define variables to keep track of that, and then we start from n equal to 0 and n equals to 1. The base case is still here, if not in the base case, and then we are going to use a for loop and perform some complicated updates here to loop until n, and then get the value of fn. As you can see, this part is basically this line, but instead of a 1-line code, it becomes like 5-line code here. Okay, and we still have to define more variable within this function. So this is the power of recursion. In some cases, recursion can make code much easier to read and much more simple. So let's verify that the result of the both functions are the same. Here, we are going to calculate f13 using Fibonacci, which is this one, and then I am using this normal Fibonacci here, which is simply mean the non-recursive version for calculating Fibonacci sequence. And then we are going to print out their results to the console. Since they are equivalent implementation, they should be the same. Okay. For the sake of time, I've already pre-compiled this program. Yes, they are the same. The recursive version here looks much simpler to human. In a computer perspective, this is actually much more efficient. Why? The reason is here. Consider this is the recursive version for computing the Fibonacci function. This is the base case, and this is the base case. Suppose we are going to compute f4, then the recursive function will go to f3 and f2. f2 will go to f1 and f0, which is the base case. So it compute f2 here, and then f3 will go to f1 base case, and then f2. And then the f2 here is actually computed again. So in the recursive version of computing Fibonacci sequence, we're actually going to have many duplicate computation. as well as memory space, because it have to keep track of the calling of the function, and then often compute the same number over and over again. If the number here is larger, you will encounter more duplication in the computation. So, although it looks nice and clean to human, in a computer perspective, this function is actually much more efficient. And if the number is large, this will be very slow. Suppose if n is 100, then this will be very, very slow. And then this will be still remain very fast. Okay? So we often need to get a trade-off between the cleanness of code and then efficiency when using recursion. So that's all for today.